In this presentation, we're going to cover the services that we'll be using in the rest of this course. Please note that even though AWS has about 30 services currently, we're going to cover just over half of them in this course. We can think of grouping these services into about 6 or 8 different families. This is the list of all the services we'll be covering in this course. Starting with the upper left, we have compute, storage and content delivery, database, application services, networking, and deployment and management, which also includes monitoring and access and authorization. Again, we're not going to dig into detail on each of these. That's what the rest of the course is for. Here, we're just going to give you a high-level overview of what each service is and what its value props are. Pretty much everything in Amazon starts with EC2. EC2 is in the compute family. It is essentially a virtual server. You'll provision this the same way that you would provision a standard server of your own, and then load your applications on top of it. EC2 currently comes in 18 different instance types, which is the hardware footprint. They can also be burned into AMIs, which are the software footprint, and allow for redeploy. They also leverage semi-stateful firewalls known as security groups to block or enable access to outside parties, and they can be put into autoscaling groups. Autoscaling allows for farms of EC2 instances to grow and shrink based on demand. Autoscaling groups can also span multiple AZs to keep any outage at a single AZ from taking down your whole infrastructure. They integrate tightly with CloudWatch and ELB, and the scaling policies can be fired manually, on a schedule, or via CloudWatch alarms. The important thing about autoscaling is that it comes at no additional cost. You're only charged for the resources that it spins up on your behalf. Last up in compute, we have Elasticache, which is a Memcache cluster and is fully Memcache compliant. In-memory caches such as Memcache are excellent places to store user sessions and cache computationally expensive operations, such as DB queries. Memcache exists only in a single AZ, and the cluster nodes are resizable, much like EC2. Because it only exists in a single AZ, multi-AZ support must be enabled by the user. Moving on to storage and content delivery, we'll cover S3, which is an object storage. It's an excellent choice for storing static assets such as images, CSS, JavaScript, and HTML. It is a write-once, read-many, or worm file system. You put a whole object in and you take a whole object out. You can't really edit objects inside of S3. Every object inside of S3 is natively web accessible, and there is no limit on the number of objects you can store. We also have EBS, which you can think of as individual disks that you attach to servers. This is user provision block storage. After you provision EBS, you attach it to a single instance at a time. EBS-backed instances can be stopped and restarted. They can also be snapshot to S3. Last up in storage and content delivery, we have CloudFront, which is Amazon's Content Delivery Network, or CDN. It can use any web-accessible server as its origin, and it uses an ever-growing list of point-of-presence or POP locations to serve this content out of. Currently, there's 37. It is a pull-based mechanism. The nodes are populated when user requests content. In database, we have DynamoDB, which is a fully managed key-value NoSQL data store. The user, yourself, provisions a write throughput and a read throughput. DynamoDB on the back end will automatically re-replicate and reshard content to multiple AZs to enable that throughput. It's SSD-backed, which means it's very, very fast, under 5 millisecond reads and under about 10 millisecond writes. Also under database, we have RDS, which is fully managed MySQL, Oracle, or SQL Server. RDS uses native integration for multi-AZ deployments, backup, and firing off read replicas. It's resizable like EC2 instances, and provisioned IOPS are available. Under application services, we have SQS, which are extremely simple queues. They're pull-based, requiring pulling and pulling messages off. They exist in the region, and they provide at least once delivery of messages. We also have SNS, or Simple Notification Service, which is a notification service for internally bound messages. This is push-based. The endpoints can be email, HTTP or HTTPS, SQS, or SMS. It enables tight integration with several AWS services, such as S3 RRS, or Reduced Redundancy Storage, CloudWatch, and autoscaling. SES, or Simple Email Service, is a service you would use to send user-bound emails, folks outside of your enterprise. It's used for transactional or marketing messages. You can send upwards of 1 million emails a day, and AWS helps you maintain your sender reputation by providing feedback loops with ISPs and alerts. Moving on to networking, we have ELBs, or Elastic Load Balancers. These are AWS managed load balancers. They provide tight integration with autoscaling groups and CloudWatch. They enable round-robin or sticky session algorithms. Moving on to VPC, or Virtual Private Networks, these are user-defined private networks inside of Amazon. They enable advanced routing, subnet, network access control lists, or NACLs, and security groups. VPC, like autoscaling, is provided at no additional cost. Route 53 is Amazon's distributed DNS service. It leverages the same point-of-presence locations as CloudFront, and it supports all major DNS types, such as A, CNAME, MX records, NS records, and SOAs. Under deployment and management, we have CloudFormation, which allows you to templatize entire stacks of resources. These templates can then be versioned and stored in a code repo. There are 200 to 300 templates readily available and provided by Amazon. We also have monitoring, which is enabled via CloudWatch. This allows you to monitor resources, billing, and so forth. Monitors can fire alarms, which in turn either control autoscaling groups or send notifications. There are native monitors for most AWS services, and you can import or export metrics to and from external resources, such as your own Nagios or Ganglia. Last up in deployment and management, we have access and authorization, which is enabled via IAM, or Identity and Access Management. This mainly allows you to control verbs and not nouns inside of AWS. To see what we mean by verbs and nouns, let's consider the sentences create instance and create only M1 small. Create is the verb and M1 small is the noun. The exceptions to this rule are S3, SQS, and SNS. AWS is rapidly expanding the service level integration of IAM, and it's one area you're going to want to watch. Again, we're going to dig into these services in more depth later, but we should now at least be able to understand at a high level what each of these services provides.